Okay, Glass for March 19th, 2025 is live. Tonight I want to welcome Haripriya as our speaker. We're going to learn about memory optimized TempDB for faster performance. Something I know nothing about. So if no one else, at least I know I'm going to learn something. And I don't have any canned introductory remarks for Glass yet. Hopefully soon, maybe I will. But welcome, glad you're here, whether you're joining live or via the recording. And I appreciate the opportunity to share a learning experience, I guess. During the presentation, Haripriya, do you want people to interrupt with questions during the presentation, or do you want them to hold them to the end?
Oh, they can ask questions whenever they want. Okay. Totally fine.
Fantastic. So for the ability to enjoy the presentation better, I'd ask you to please stay muted until you do have a question so that we can focus on her presentation. I think as far as opening remarks, that's all I have. I'll turn it over to you. Thank you.
Thanks, Joe. Good evening, everyone. Thanks for joining. Today's topic is memory optimized TempDB for faster performance. When I say memory optimized, or if I call it in-memory TempDB, both the terms are interchangeable. So when I say either of these, it means the same. Disclaimer. All right. And let me put my mouse here. About myself, this is Haripriya. I've been working as a SQL Server database administrator for 11 years now, based out of Boston. And I work a lot on AWS EC2 instances, and I'm an AWS.
Apologies for the interruption. Are you want to share your presentation?
Okay, I just realized I wasn't sharing. Thank you, Jeff. All right, do you see it now?
Do the same thing. I'm so used to sharing one of my monitors that I feel like I'm always sharing my monitor.
Yeah. All right. Thank you. Yes. So the topic is memory optimized TempDB for faster performance. And yes. So about myself, I've been working as a SQL Server database administrator for 11 years now in Boston. And I'm very passionate about databases, and I can roll my sleeves up and dive into the SQL Server engine internals for hours. And performance optimization has always been intriguing for me. I recently started my speaking journey with New Stars of Data like 11 months ago, last year. And then I spoke at SQL Saturdays in Boston, San Diego, and Albany. And I also got the opportunity to speak at PASS Summit in Seattle a few months ago. So that's about my speaking journey, and I'm continuing to do it. And I love to present and talk about technical topics. And I won a couple awards at work last year. I won Rookie of the Year for outstanding performance. And this year in January, I won the Bookworm Award for continuously learning and also mentoring the team. That's about me. And on my personal end, I have 2 kids and my husband, so that equals almost like 3 kids. Well, let me not make any jokes on my husband because he's watching the kids right now. All right. And you can find this slide deck, the demo scripts that I will be showing you in this GitHub link here. And you can also DM me on LinkedIn if you have any questions after this presentation. And I write a bunch of SQL Server articles on Substack. So if you're interested, you can go take a look at it. Coming to the topic, the agenda for today, I will be discussing about this new feature, like what is it used for, when this should be used, the key benefits of this feature, and most importantly, when this feature should not be used and what are the disadvantages of it. And this will be an intermediate level session, 300 plus, because I'll be discussing, beyond the basics. But if you do have questions on basics or working of TempDB, we can catch up at the end of the session. All right. So what's the problem I'm trying to solve here? I was working on production server and I noticed TempDB contention. just like most of us, I just added data files on TempDB and assumed it's going to resolve the issue. But then I noticed it was not resolving the issue. I was just wondering there, oh, I just added TempDB data files. Shouldn't it be resolving the contention? Well, no. That's when I researched and I found out there can be two types of TempDB contention. So when you see page latches on TempDB, you could have contention on PFS GAM pages, or contention or page latches on system objects. If you have this PFS GAM, please go watch my video or any video on TempDB contention. The reason I mentioned my video is because I've talked a lot about PFS GAM pages and how to resolve TempDB contention when you see page latches on those three internal pages. Well, that's not the topic for today. Today's topic will be about memory optimized TempDB feature, which is nothing but page latches on system objects. So it is very important you understand that when you see page latches on system objects, that's the issue we are trying to solve in this discussion today. And that's where this memory optimized TempDB feature comes into place. So forget about PFS GAM. That's not at all the topic for today. And if you see this on your production servers, this memory optimized TempDB feature will not help. It's only about page latches on system objects that this feature is going to resolve. I want to bring it up front and make it very clear what we are discussing about. All right. And this feature, it's a new feature that came out in SQL 2019, and it comes disabled by default. If you want to turn it on, you can enable it, but you have to restart the service when you enable this feature. What this feature does is it moves the heavily utilized system objects to memory. When those system objects are moved to memory, then those objects are now latch-free or lock-free. It's because when the operations need to access those system objects, they will all be in a place in memory that do not need any page latches, and that reduces contention. And this is also non-durable because it is all about TempDB. You don't need any durability here because when the SQL service restarts, it's going to get started from scratch. All right. And again, like I said, this addresses page latches only on system objects. The moment you see page latch, don't enable this feature. It's not going to help. Only if you see page latch on system objects, this feature will help. So these are the 12 system objects that are moved to memory. If you see here sys call, sys row sets, and many of the system objects, only the system objects, not the user tables or not any other tables that we create. It's just about the metadata objects here that are moved to memory. And this has been there since 2019 version, but I think in 2019, probably in the earlier patches, you will only see 10 objects being moved. Only in the latest patches, they added another 2 objects and you will see all 12 objects being moved. So if you're on 2019, I recommend doing like the latest patches on 2019. So these are the 12 objects basically that are moved to memory. If you see any other object that's having this page latch that's not in this list, then again, this feature will not help. All right. And how do you enable this feature? You run this alter server configuration, set memory optimized TempDB metadata on. When you run this, you have to restart the SQL service because this does not come enabled by default. It is actually disabled. The reason being, it may or may not suit your workloads or environment. So you check out how things are and you test it extensively and then enable it if it suits your environment. That's the reason it is disabled by default. And it needs a restart because Hackathon DLLs need to get configured. So when you restart the service, all those DLLs will get configured. So that's how you enable this feature. And to run this, of course, you need sysadmin permissions. Developers or someone cannot enable this configuration.
So I have a question.
Yes.
This is fine for an on-premises database. Do you know if this applies to an Azure SQL service?
This does not apply to Azure SQL Managed or something. And I actually have it in the, just give me a second, I'm sorry. Sorry, that was my son banging the door. Yes, it is not available on Azure SQL Managed and the other instance that I have coming in the upcoming slides. All right. And so this is how you enable this feature. Let me put it here. And why should you use this feature? It is because when those system objects are moved to memory, they become latch-free and lock-free. So all those page latches are getting reduced. When those page latches are getting reduced, then you see less contention. When you see less contention, that gives you better performance. Also, I mentioned the term here, metadata contention. Metadata contention means contention on system objects. So you will see very less metadata contention, which is the main benefit of this feature. While I'm talking about it, I also want to show you what metadata contention is. So when you run DDL operations like create, alter, or drop temp tables, those operations need to get a latch onto the system objects. Under normal circumstances, those DDL operations can easily acquire a latch onto system objects. But on a very busy OLTP environment, when you have too many operations running concurrently, that leads to contention. It's because now all these DDL operations, they will be waiting in line to get that latch onto the system objects. And that causes contention. Because this is all about system objects contention, it's called metadata contention because system objects are nothing but metadata objects. So to resolve this metadata contention, we are using that memory optimized TempDB feature. So for example, if you were to look at this picture, you see how there are multiple drop operations. They are trying to get a latch onto this system object table. So when there are too many operations running concurrently, now they are all waiting in line to get that latch, and that causes contention on this system object. So when does this happen? On very busy OLTP environments, when you have these stored procedures, and when the stored procedures have, create temp table, do this, and then alter or create temp table. When you have stored procedures like these and you run multiple stored procedures concurrently, because in our environment, sometimes we have a stored procedure running every second, right? So for those stored procedures, something similar to those, when they are running concurrently, then you will see this contention. All right, so usually it happens on OLTP. Well, it may happen on OLAP, but it's unusual or a common occurrence in OLTP environments, in very busy OLTP environments during business hours. So when should you use this feature? When you see page latches on database ID 2. The first number here is the database ID. 2 is always for TempDB. And 9 is the file ID and 8 is the page ID. Don't worry about these two numbers. It's just the first number, that is TempDB2, and objects, system object. So when you see page latches on TempDB, on any of the system objects, you remember the 12 objects that I just showed. So if you see any of these 12 objects here, then you can use this feature. So it's strictly for TempDB, system objects, and for page latch wait time. This is what this feature is going to resolve. You cannot use this feature for any other objects here, user objects or PFS GAM pages or anything else. This will not work. This feature is specifically designed only to address these three issues together. The versions that it is supported are 2019 and 22. But not in standard edition. You will get this only in developer and enterprise edition. And when you move these heavily utilized system objects to memory, where in memory is it stored? It's not in the buffer pool or in the planned cache. It is in a separate place in memory where no latches are needed to get the information. So that is in a separate part of memory, latch-free and lock-free, which is the greatest benefit of this feature. And when you move those 12 system objects, it occupies around 80 megabytes or 100. I've seen it like 80, 100, or 120, but not more than that when you initially turn it on. But after that, as transactions keep coming in and when they utilize this memory optimized TempDB, it keeps building up. And when you set this feature up, you don't need any file groups. Remember, we don't want this to be durable because you can restart it and everything will get started from scratch because this is TempDB. So there are no file groups needed. You just enable the configuration, restart the SQL service, and you're all set to use it. You can also use resource pool in this case. You set up minimum memory and then you set up maximum memory because this can keep using whatever memory you have, like the max server memory. We want that to limit. So we can set up max memory. But the thing here is you have to bind it to TempDB. And after you bind that resource pool to the TempDB, again, you have to restart the SQL service. I know we restarted the service once when you enable the configuration. Now, again, you have to restart the SQL service. All right. You run this query here, which I will be showing everything in the demo. So you just bind that resource pool to the TempDB metadata and restart the service. But there is a catch with this resource pool here. The thing is, it works most of the time. When you set up the resource pool, it will use memory up to whatever extent you have set it. But when you are crossing that limit, I mean, you meaning not you, when the feature tries to use more memory than what you have set for the resource pool, it errors out with out of memory errors. The queries do not run and they error out with out of memory errors. And you can also see it will restart the SQL service, which is not at all good. And I've seen that happening. Resource pool does work though, but that feature does not respect resource pool to its fullest extent. It does work most of the times, but there are times when it does not listen to the maximum memory setup, and when it does not get the memory it needs, it will also issue a restart of the SQL service. That could also happen. All right. Let's go ahead with the demo. So in the demo, what I'm going to be doing is I will be using the SQL 2022 version. First thing what we will do is, with the feature disabled, which comes by default, I will run a stored procedure which has create temp tables inside it. And then I will run another stored procedure which has table variables, like create table variables inside it. I will run these and then capture the graph of the contention, like the spikes, the page latch spikes. The next thing what I'll do is I will enable the feature and then run the same thing. And we can see how much this feature has helped us in reducing the page latches. And note, this is not the performance comparison between temp tables or table variables. This is just to show how much this feature helps with temp tables or with table variables. This is all about this feature and how much it helps. So we will do that, and I will also show you how the memory cleanup takes place and what are the issues that are still remaining with memory cleanup and what are the other limitations of this feature. Any questions? How many terabytes of server memory are recommended? Are you asking like how many terabytes are recommended to set up on the resource pool for this feature? I would say usually at least give it to 80%. Don't do like 50 or 60, because when you do 50, 60, that is sure not going to satisfy this feature when many transactions are coming in, and there will be a possibility of restart of service. So what we have on our production servers is like 75 and 80%. So that's what I have seen on my servers, and that has been working well. But at times there are restarts as well, so that is not totally trustworthy too. But to begin with, I would do 75 or 80 as max server memory on the resource pool. right. Any more questions before we go ahead with the demo? Okay, Jeff is asking, are you talking about server memory or RAM? Yeah, I think Rich is talking about like of how much RAM should I give this to resourceful max memory is what I'm guessing. All right. Okay, let's go ahead with the demo. Get this out. And so the first thing, we will be using SQL 22 version. Let me put this here. And I have 14 processors. And in this server, I actually have 32 gig, but I'm using 28. Let me check. I think I do have 28. Yes, I've set up 28 gig for this 22 version that I'm using. All right. And what I'm going to be doing now is create a stored procedure with temp table inside it, 3 columns, and insert 10 records into this. So let me create this stored procedure here. And the next thing that I'm going to be doing is create another stored procedure, almost the same one, but the only difference being instead of the temp table, I'm doing table variable here. Exactly the same thing, but instead of temp table, it's going to be table variable. So let me go ahead and create another stored procedure that has table variable. What I will do next is use this ostress utility. This is actually a free command line utility from Microsoft where you can troubleshoot issues by stressing your SQL Server, by giving it a heavy workload. You can also grab from production servers and run the trace on this utility and troubleshoot issues that come out of it. So I'm using ostress utility server name and then execute the stored procedure on 50 concurrent connections for 1,000 times. So that's what I'm going to be doing. And before this, I also want to show you the contention script that I'm going to be using. So what this does is it grabs results from dm exec request dmv that will give you the currently active requests, and dm exec SQL text. This will give the text of that currently active request when used in conjunction with this. All right. And FN page res cracker and DMDB page info. These two are 2 new functions in 2019 that can give you a lot of information about page related ways, because right now we are interested in page latch and we are also interested in only the system objects. We don't want to know about anything else. We are only interested in page latches that are on system objects. So I have filtered them by page latches and system objects. Also, I want to mention that this is only about page latches. Don't get confused with page IO latch. That is a different wait type, which grabs pages from disk to memory. So we don't want to talk about it now and get confused. It's only about page latches today. That's on system objects. All right. So when I run the workload, I will be using the script to check contention. So here is the workload, ostress.exe and this one. And I also want to show you perfmon before I kick off anything. So here is the perfmon counter that I have. Batch requests per second will be the throughput, the workload that I will run, and page latch waits will give me the graph of what page latches I have. All right. So first, let me go ahead and run this. Okay, I think I should start the perfmon first and then run this. So 50 threads, it's processing. Let's see how it is here. Green is the throughput, the workload here. Red is the page latches. If you see the page latches right now, it's at 53,000. You can see the number here. It's now 49,000. All right. This is the stored procedure that has the temp table in it, like create temp table. So we see almost like 50, 60,000 page latches and the workload is done. All right, let's stop it here. Let's stop it here. And I also want to note down the time. It took almost 25 seconds. So I'm going to note down the time here, 25 seconds. So this is temp table execution time in that stored procedure. Without the feature, it took 25 seconds. All right. And I know we saw in the perfmon, I'm going to run this again without any change because I want to show you how these page latches look like in the SSMS. I'm going to run this exact thing again because I want to show you here. Now, if I check contention, okay, this is what I wanted to show you. On SSMS, you will see page latches. On TempDB database ID 2, on system objects. So when you have these three conditions satisfied, page latch, TempDB database ID 2, and any of those 12 system objects, then you know it is metadata contention. The moment you have metadata contention, this feature will help you out. I'm scrolling all the way to the end and also to the bottom. All I see is metadata contention. Okay, so this is how, if you see on your SSMS, when you run the queries, then you know this feature can benefit you. All right. Okay, so I wanted to show you this in SSMS. Now let me go back to the script that I have here. I ran this temp table. Now what I want to do is run this stored procedure where I have the table variable instead of the temp table, the one that we just created. I want to run the stored procedure with table variable and see how page latches are in this case. All right, let me start perfmon again and run the table variable stored procedure and go to this perfmon. Green is the throughput and red is the page latches. And you see right now, I think it's at 27,000. It's going to 60,000. All right. So we do have page latches in both the cases. All right. So this is a very good use case for this feature. Let me stop it because it's all done. I'm also going to note down the time. It took 10 seconds now. Table variable execution time without feature is 10 seconds. So what did we do now? We created the stored procedure, one with create temp table inside it, and we executed it. So we have this graph from it. The next thing what we did is we have another stored procedure with a table variable, and we executed it. And this is the graph we have now for page latches. Page latch is nothing but contention. All right. And we also noted down the time. In one case, it took 25 seconds. In the table variable case, it took 10 seconds. This is not at all about the comparison of performance between temp table and table variables. Please don't take that into account. This is just about without the feature, how things behave, with the feature, how things behave. All right. Now what I'm going to be doing is I will enable this feature and we will run the exact same thing to see how much it helped. All right. So to enable this feature, before that, let me check what the server property number is like. So you can do this select server property as TempDB metadata memory optimized, and it will give you this value. 0 is disabled because it comes disabled by default, and I have not enabled it yet. I can do this alter server configuration and turn it on. And for this to take effect, I need to restart the SQL service. All right, where is the thing? Should see something, yes or no. Okay, here it is. Let me bring it up this side. Okay. And when you enable this feature, make sure if you're especially doing, multi-nodes, make sure you enable it both on active and passive nodes and also on secondary nodes. So when you do the failover, it is consistent across all the nodes. And now the restart is done. Let's check. You will see 1, which means it is enabled. I also want to show you how it is in the log. When this metadata, TempDB metadata is moved to memory, let me show you how the log looks like. Especially you can also verify it from here. I think I see it here. Yes. TempDB started. I'm not sure if you can see it. Okay. TempDB started with memory optimized metadata. So that's what you will see in the log file registered when you enable this feature. All right. Now let's go back and we just verified it is 1. So that's good. So this feature will be moving those 12 system objects to memory. Let's verify that. You can verify that using this object here, memory optimized tables. This will tell you what objects have been moved to memory, and you will see all the 12 objects are moved. Now, I want to take a moment to show you that when we had contention, previously when I ran the workload, this is the contention we saw, right? You see how this sys schema objects and, okay, at this place we have only 1, okay. You see how this sys schema objects has this page latch. when we actually, before we enabled the feature, this had the page latch. Now that we enabled the feature, this sysschema objects is part of it. This has been moved to memory. So the next time when I run the workload, you will not see page latches on this object. That's because this object has now been moved to memory. So that's what I wanted to show you. The page latches on those system objects will not be there anymore because that has been moved to memory. And how much memory is it actually occupying? Now that we moved it, let's find out how much memory it's occupying. 63 meg, it's nothing, right? And you see this DMV here, DMOS memory clerks will give you the list of clerks and how much memory each of it is occupying. In this case, we are only interested in DBID2, which is TempDB. That's why I filtered it by TempDB, and you could see it as 63 MB here. All right, so that's about like the how many tables have moved and how much memory it is occupying and things like that. So now we have enabled this feature. What I'm going to do is I'm going to run this Postgres utility again with feature enabled to see if the page latches have reduced. So I'm going to start perfmon in a whole new page here. This one, I already have the perfmon graph here. I don't want to disturb this. Let's just have it like this. I'm going to start a new perfmon here and then run the stored proc now, which has that create temp table inside of it. And let's see how it is running. Green is the throughput. Red, you see the page latches, it's a flat line. It's 0. It's not even spiking up. Absolutely nothing with this feature turned on. Wow, you see it? Okay, it finished in 15 seconds. So this took 15 seconds. Let me note it down here. So this stored proc with feature enabled, it took 15 seconds now. What I'm going to do now is run this stored proc, which had the table variable, the same workload which we ran earlier, but this time with the table variable. I'm going to run it here and let's capture the graph if it helped in this case. Green is the throughput, the workload that we are running here, and red is the page latches. Absolutely 0 again. Nothing at all. You see, this is the beauty of this feature. When you have page latches on system objects, this is going to help you a lot. And to compare, let me bring this thing here so you can see. You see in this case where we run the stored procedure, almost 60,000 page latches. In this case, 0. And before the feature again, when we ran this table variable stored procedure, it went up to 70,000. In this case, 0. So that's the huge difference in page latches when you enable this feature. So the key point for you to enable this feature would be, if you see page latches on system objects, then go ahead and enable the feature and that will help you bunch. All right. And how long did this take? 14 seconds. All right, let's put this here. Okay, so if you see, we did have a difference in execution time without the feature and with the feature. That's like 10 seconds. This one, it did increase by 4 seconds, but in the demos that I have done previously and in a lot of testing, usually this is around 10 seconds. Maybe it might be like one-off case, but with this feature enabled, you will not see any performance improvement for table variables. It does reduce the page latch contention, which is good, but it does not reduce the execution time. All right, so our main focus being reducing the page latch contention. This feature does it beautifully when you have stored procedures with temp tables in them or with table variables in them. Any questions? Nothing? Okay. Jeff, you can ask questions. I was just kidding.
I'm working on getting rid of this echo.
Okay. I can mute.
Do I still have an echo? You give a thumbs up. Does that mean I still have an echo?
You do not. As soon as Haripriya muted, the echo went away.
Okay. Alrighty. Thank you.
All right, it's my turn now. What is it? We are taking turns now. Mute and talk. Anyway, as long as we have things working. Okay, so I believe no questions. All right. So this is about this feature and how it helps in 22 version. with stored procedures with temp tables and with table variables. It's really going to help you a lot. All right, and let's now go to the part. Well, I think this was the easy part, whatever we dealt with. Now let's go to the memory cleanup part. So if you see for these stored procedures, how much memory it occupied when it uses this memory optimized TempDB. Now you could see with whatever we ran, it has occupied 250 meg. Earlier we had like I think 60 something when we initially enabled the feature. Now it has gone up to 250. What we could do is clean this up. Well, it will also clean up as a background task, but this feature does not do a great job in cleanup. So I always set up this, set up a job or something to clean this up regularly, which I will show you here. This system stored procedure, SPXTP force GC, will help you get rid of those unused or those allocated bytes which are not in use, basically unused bytes. So now that our stored procedures have finished, you don't need all that 250 megabytes in there for it to hold. So let's go ahead and clean this up. In 2019, if you have this on 2019, the recommendation was to run each of this statement twice. That's how it worked. That's the first version it got released, so I don't blame them. But in 2022, if you have CU1 or above, it's enough to run just once, but I just got so used to running it twice, so I'll just keep it that way. I will go ahead and run it now, and this should clean up the memory. And now let's check it, how much it has. Okay, it's back to 50 something. So we had 250 and it's now back to 50. So this did clean up. This works under normal circumstances. You have queries going in, which are using TempDB, and they are committed. They're all good. So the cleanup happens, the feature is happy, and your SQL Server is also happy. All this is when things are going as expected. And when things are not going as expected, which is almost every day, what happens is this cleanup does not take place. Well, when this cleanup does not take place, the restarts happen. All the bad things happen then. So I'm going to show you a demo.
Haripriya, just a quick suggestion. If you went down to the lower left-hand corner of the screen, you're at 79% magnification. If you were to change that to 150, old farts like me could actually read your screen. There we go. Mike, I don't know if that's too big, maybe 100%. Perfect. Thank you.
All right. Yeah, thanks for bringing that up, Jeff. And does it apply to all the windows or just this? I think it is, right? Okay. So what were we talking about? Okay, so the cleanup does happen well when you have transactions committed and things like that. But when you do have some open transactions or some sleeping transactions out there, that's where the problem arises. For example, let's do this begin tran and create table, just a temp table. And I'm not committing this on purpose because I want to show you how the cleanup does not take place. All right, so let me do this begin tran create table. So now this is not committed. This will be a sleeping open transaction. On a production server, imagine if you have something like this, you're also going to have multiple transactions coming in that are committed. So let's mimic that and run this stored procedure just to mimic like a production server or so. I'm going to run this now. That's just to show you like you have one sleeping transaction and you have multiple committed transactions that are coming after it. All right, so if you check this, this is still running. Let's check how much memory it's occupying, 286. It will still go up because it's still running. All right, this is still, okay, this just finished. So let's see, it's at 321 meg. Now let's try to clean up, run these stored procedures that we just used earlier. This will not clean up that 300 meg. That is because the earliest transaction in this case is this open transaction. So this will hold up the memory cleanup of whatever committed transactions are there. It will still hold up the memory cleanup. So if you check it now, it still says 300. Even if you were to run this 1,000 times, this will not clean up. It's because you still have this open transaction out there. All right. So what did we just see? We have an open transaction on purpose for this demo. So we have an open transaction and we ran a bunch of stored procedures and we tried to clean it up. It will not get cleaned up. Now imagine this is on a production server. You have multiple transactions coming in that are accessing TempDB. So this will keep building up. When this keeps building up, it will reach that max memory and it will blow up. It will cause a restart of the SQL service. All right. So that's one, I will say it's one disadvantage of this feature. Well, I call it a bug, but Microsoft may call it, it's not a bug, it's a feature. Well, all right. Well, I think there are trade-offs with anything, right? Nothing comes for free. There's no free lunch or free coffee. So I think it is solving a beautiful issue here. I love that part. It is reducing all those page latches. That's awesome. But it comes with the trade-off, like it may cause a server restart. But in this place, I do have a remedy for that. We can fix it. What we are going to be doing is, I'll show you, you can set up jobs and things like that. But I want you to follow that. If you have an open long running transaction, it will hold up the memory cleanup and it can cause issues. All right. So in this case, if we were to check again, it's still 300. It's not going to get cleaned up because we have that open transaction out there. I'm going to use this query, which checks this active transaction, session, exec sessions, a bunch of DMVs. And this will give me what transactions are open right now. The 92 session ID must be probably the one I ran this begin tran, right? See this one I ran with the 92 ID. So this 92 session ID, it's been out there for 3 minutes and I have not committed it. So this is an open transaction, which is holding the cleanup. So you can use this on your SQL Server to find out, especially when you see the memory building up and it's not releasing, you can use this query to see what those open transactions are. And what I'm going to do now is kill this 92 session. And let's check again before killing. It's still at 300. Let's kill this open transaction here. And let's check it again. It's 300. Let's go ahead and run this cleanup, manual cleanup. This should now go down. It won't be 300 anymore. Look at this, 59. So the point I'm trying to make here is, with this feature turned on, if by any chance you happen to have a long open sleeping transaction, it will hold up the memory cleanup for whatever transactions that come after it. So it's very important you notice that and terminate that transaction so it will not cause a restart of the SQL Server instance. All right, so that will be the key takeaway here. And for you to reap the maximum benefits of this feature, I highly recommend you set up these 2 jobs. First job would be to release memory. This one, this script here, set up a job to run this script, which can release the memory, like for every 30 minutes, for an hour or 2 hours. Test it out on your service and see what suits you exactly. So set this job up manually because this feature does not do a great job in cleaning up by itself. So set this job up. And the second thing I would say is set up another job to terminate long open sleeping transactions. You can add various filters to this query here. This is the one I used to check that long open sleeping transaction. You may not have to kill every open transaction because some applications are designed to always have that open tran out there. So you don't have to kill everything. Look at your environment, see what might be causing the issue and add filters accordingly and just terminate those transactions. You can terminate probably, you can run that job once a day or once in 2 days, again, based on your environment. What I can tell you, like a solid advice is, do set up these 2 jobs to release the memory and to terminate long open sleeping transactions. Once you set these 2 jobs up, this feature works beautiful. It still works beautiful, but you will have those disadvantages and you don't want to have that. You want to get rid of those, two disadvantages, set this thing up. All right. So that's about, this feature, how it works, and how the cleanup takes place. Any questions? Are these scripts and video shared later? Yes, of course. I think Joe is recording this video, so you'll have it. And I have the scripts up on my GitHub, which are in the presentation. I can show it once again. And Jeff asked, so if I have a stored procedure that uses 100 gig of TempDB, is that going to end up in the memory that you demoed clearing? So if I have a stored procedure, you're asking if it's going to, if you have a stored procedure where you have create temp table or anything that is related to DDL of the temp table, yes, it will use up memory optimized TempDB metadata. It will use this feature. And when it uses it, it should have enough memory to run. If it doesn't have that enough memory, then either you're going to get out of memory errors or it may cause that restart of the service. All right. Yes, so it will end up in the memory. So if you're using the stored procedure, it will end up in the memory that I'm showing. As long as it has any DDL statement, DDL of the temp table in the stored procedure, it will end up this memory. If you don't have to do anything about the DDL of temp tables, then it won't use this memory. This is just about DDL of those temp tables, like create temp table, alter temp table. If you have any of these two in your stored procedure, then it will use this feature and it will end up in that memory. Not just in the stored procedure. If you just use create temp table, alter temp table, it will use this feature and it will use up the memory. All right. Okay. So that's about this one. So, to use this feature, make sure you set up those two jobs. Then you can have that maximum benefit of having it enabled. And the next thing that I want to show you is set up resource pool. You can set up resource pool, and usually at work we do have it like 75-80%, but for demo purpose I set it to 2 so I can get the error out there quickly and show you how it looks like. All right, so I did the resource pool with, you can also set up min CPU, max CPU, however it suits you, but don't do max memory like 30-40%. This memory optimized TempDB uses a bunch of memory, and if it's not enough, it's going to throw out of memory errors. So at work on your production, use like 75 or 80, but again, test the workload on your dev environment or staging and see what works for you. All right, so let me run this now. I'm going to set up the resource pool and see how this feature works with the resource pool. And I have to run this command reconfigure for it to work. Once I set this resource pool, I need to bind this with this memory optimized TempDB. So I have to run this alter server configuration. For this to take effect, again, I have to restart the SQL service. I'm like, how many times do I restart the SQL service? But that's how they have it. And I do get it because this is a demo server. It just gets back like in a second or two. But on production server, I think you have to do it on a weekend for you to restart these many times, right? Once when you enable the feature, you have to restart. And when you bind the resource pool, you have to restart. So this requires 2 restarts in case you're planning to put it on your servers. All right. Now let's check if it is bound to TempDB. So database ID 2, that's good. TempDB, and this is the resource pool that we created, and max memory percentage I have 2. Don't follow this on your production. I just have it 2 for demo purposes so I can show you the errors. And this is the memory occupied. Right now we have 55 meg. Now let me run this open transaction again. The reason I'm running this open transaction is it's just to show you when I run this transaction and when I run the stored procedures, I want to show you that it goes beyond the max server memory we set up in the resource pool and how it errors out. Just to show you the error, I have these, all right? Because I don't want to get this cleaned up immediately. I want to generate the errors and show you how it looks like. All right. So all I have is just 2% of max memory, which is like my 100% is 28 gig. So 2% would be like 0.5 or something, 0.5 gig or less than that. So, okay, there we go. Okay, so it did not have enough memory right now because I set it to very, very less 2%. So this is what you will get. If it crosses that max memory percentage, there is insufficient memory in the resource pool to run this operation on memory optimized tables. So this is the error it is going to throw out when it does not get enough memory granted from the resource pool. All right. So when you set up the resource pool, make sure you at least have 70 or 80%, so it can help you out. You don't get this error. But warning, there are cases where it will still cause a restart of the SQL service. It does not always listen to this resource pool. It's not a problem with the resource pool. Resource pool does its job. I think it's a problem with the feature. Sometimes it does cause restart. All right. So that's what I wanted to point out here. When it crosses that max memory you set up in the resource pool, it throws this error, there is insufficient memory. And in rare cases, it causes a restart too. Let me bring up that screenshot that I just showed you here. Right? Where was that screenshot? I wanted to show you about the resource pool. Oh, here we go. You see this here? This is the screenshot about the resource pool. They have it up on Microsoft website. That's why I just wanted to show you, especially if you read this here, under certain circumstances, the SQL Server service could potentially stop if an out of memory error occurs. So to reduce this, set this to max memory percentage to a high value. Well, I will say, even if I set it to a high value, it can still cause that restart of the SQL service. And I have seen that. So does resource pool help you? Well, it does to some extent. It does not always help, not in 100% of the cases. So that's what I wanted to bring it up here. It does help, but not always. So you have to be cautious if you want to set up the resource pool, and don't assume that it's going to listen to it. It does not in all the cases. All right. So that's one thing I wanted to show you. So these are some of the limitations we have with this feature. While I show you the best things about the feature, I also want to show you what are not so good things about this feature, because that's important to learn before you enable this feature, right? And all right, so I have this resource pool thing showed to you. Next thing is, there's one more limitation. If you have a column store clustered index on a temp table, then that stored procedure will not execute. Let me show you that example here. So I'm creating this stored procedure, create temp table, and I'm creating a clustered column store index on temp table. In case you're wondering, who creates a column store index on a temp table? Honestly, I don't know. I don't have it on any of my servers. In case you do have it, then it'll be good for you to know. All right. Maybe there are some cases where people create, but I don't know a case that I have seen or I have created. But if you know, please do share it. I'll be happy to learn. All right. But I want to show you the limitation in case in future, if you were to encounter something like this, it'll be nice to be, oh, yeah, I saw this somewhere, you know. All right. So let me go ahead and create the stored procedure. Creation will not be a problem. You can create the stored procedure when you have clustered column store index on the temp table, but executing it will give you this error. Column store index creation is not supported in TempDB when memory optimized metadata is enabled. You see this? That is why if you have temp tables with column store clustered indexes on them, then either you have to rewrite the code if you want that feature, or don't turn on the feature, because stored procedures with column store clustered indexes on temp tables will not work. All right. And because of this, you won't be able to run this SP estimate data compression savings in case you're running this to find out how much data, how much space you might be saving. These stored procedures will not work for compression type column store. I mean, the stored procedure will work just for this column store compression type or column store archive compression type. These stored procedures will not work. If I execute, again, you will get the same error. Column store index is not supported when you have memory optimized. Again, the same thing here. All right. So these are some limitations with resource pool, with column store cluster index. And the last one I want to show you is when you have memory optimized user table query and a query or the statement that is talking to TempDB, the system objects. When you have these two queries, memory optimized user table, okay, this is on a user table, and you have a query talking to memory optimized TempDB, those two queries cannot exist in the same transaction. It will fail. Let me show you. So on a user database, I'm creating this memory optimized user table. All right, this is memory optimized user table. This has nothing to do with the TempDB now. So let me create this. I'm creating this memory optimized user table. I already have the file group and everything created earlier. All I want to show you is if I have a memory optimized user table, I'm creating this simple transaction here, just one transaction where you have a query that's talking to systables on TempDB. And we know this TempDB is memory optimized here because we have this feature enabled, right? And then in the same transaction, I'm talking to this memory optimized user table that I just created. What happens? It fails. You see this? A user transaction that accesses memory optimized tables or natively compiled modules cannot access more than one user database or databases, and it cannot write to master. So in a single transaction, you cannot use memory optimized table and memory optimized TempDB. It is not compatible. So the key point that I want to tell is in the same transaction, you cannot have both those statements in there, in memory user tables or in memory TempDB. All right, so that's about the demo. Any questions? No questions? All good? All right, Joe is typing something. I can mute myself.
No, you're fine.
All right.
Continue.
Yeah. Let's jump to the slide deck. Let's look at the results from what we did in the demo. So if you see temp table creation runtime without the feature, it definitely had like 25 seconds with the demo that we did. And with the feature, it ran like, I think 14 or 15 seconds, I think. So the runtime is definitely faster. And then if you see with the stored procedures that have the table variables, it was kind of low runtime, and without the feature and with the feature, there was not like a performance improvement, but there were reduction in page latches, which is what we exactly want, right? If you see page latch contention, this was definitely high. We saw 60,000 or 80,000 page latches when the feature was disabled. When we enabled it, we saw absolutely zero page latches. That's the best part about this feature. And query performance, of course, when you have page latches, it's going to be a bit slower. And when you don't have page latches, which means there's no contention on the server, it's going to be a little bit faster. So that's about this demo. Again, when you have page latches on system objects, this feature will help, which also means when you have DDL of temp tables or table variables in the stored procedure, this feature will help. There are some limitations. This feature is not available in Azure SQL Database or Azure SQL Managed Instance. I know some people have been asking for this feature, and I have no clue if they're going to release it out there yet. And I strongly recommend not to enable this feature on 2019. That's the first version it came out. But I've seen a lot of errors, not just out of memory errors, but a bunch of other errors too. And that is why I do not recommend enabling it on 2019. It works reliably on 22. From what I've seen in 2019, it works much better on 22. So you could go ahead and enable it on 22, but not on 19. And if you still want to do it, go test it out a lot and then enable it. And you see that the memory, this in-memory TempDB metadata, how much ever memory it's occupying, it just grows without limit. Even if you give it like petabytes, I think it will just keep growing. So we have to take care of the memory cleanup. So how do we manage this feature efficiently? It's very important because it's a very good feature, but it's just that you have to know how to tackle that problem child, even if it has very good efficiency, right? So I see it as one of those cases. First thing, like I said, set up the job to release the memory periodically, maybe once every 30 minutes or an hour or 2 hours, just based on your environment. And second job, terminate those long open sleeping transactions. Again, according to your environment, set it up like every day or 2 days, a week, whatever suits you. I strongly recommend to set up these 2 jobs if you want to reap those maximum benefits of this feature. When to avoid this feature? We know when you should be using this and what are the limitations, but also it's important that you know when to avoid this feature. If you have stored procedures or if you have transactions that are explicit, like you have begin, tran, and commit, and you have multiple things going on inside it, and it's a very long transaction, and that's how your workload is, then do not use this feature. Because memory is going to keep building up and it will take forever for it to, to either release, or it's going to cause that out of memory errors. So if you don't have shorter transactions, do not use this feature. If you do know that your transactions are long, you have explicit ones, multiple things going on inside, do not use this feature. And if you have temp tables with column store clustered indexes, again, do not use this feature. But if you still want to use it, you can go rewrite your code. But if this is how you have it, you can't rewrite the code, then that's a good point to avoid this feature. I will also tell you, before enabling this feature, to reduce those page latches, you can do a couple more things. To cache the temporary objects and also avoid dropping the temp tables at the end of the stored procedure. In my previous presentation about TempDB contention as whole, I've talked about these topics as well, which I have the link at the end, and you can go take a look at it or listen to it when you have some time. I've talked about caching the temporary objects and why you should be avoiding dropping temporary objects and things like that. So what I recommend is try these 2 things and then enable the feature. It'll help you even better. Summary. You will use this feature when you have page latches on system objects, especially when you have too many stored procedures that have temp tables in them or table variables in them running concurrently on busy OLTP environments. This will not help when you have contention on PFS GAM or SGAM pages. It's only for system objects. This feature comes disabled by default, and when you enable it, you have to restart the SQL service for it to take effect because the Hackathon DLLs get configured. And you don't need file groups for this one because in-memory OLTP engine, you need it. But for in-memory TempDB, you don't need file groups. When you enable this feature, make sure you enable it on your passive nodes, secondary nodes as well. So when you fail over, the configuration is consistent across all the nodes. This feature works very good when you have temp tables or table variables in the stored procedures. There's not much performance difference with the table variables, but it still works, which is good by itself. You can see a significant performance improvement when you have temp tables in the stored procedures. And if you have column stored indexes, this feature is not going to help you. And in the same transaction, you cannot have in-memory user tables and in-memory TempDB in the same transaction. If you have this feature enabled, it's again not going to work. So these are some of the limitations you have to keep in mind if you want to turn this feature on. And resource pool does help, but not always. The main thing that you have to do is, to get the best out of this feature, keep your transactions short, especially those DDL transactions, keep them short. This is available starting from 2019, but its best thing is to enable it only on 22 for now. It's not available in standard edition. You have it in both developer or enterprise, and it's not available in Azure SQL managed instances. And most important thing is, you have to set up the jobs to terminate these long open sleeping transactions and to release memory periodically. These are some of very good resources. And the last link that I have here is the one I talked about, TempDB contention, a while ago. It has about 2 types of contention, because right now we discussed only that memory optimized TempDB. If you want to learn about caching temporary objects and the other type of contention, you can take a look at the video. And these 3 links are from Microsoft. They're also great articles that you can get more information about. Any questions? I will mute myself in case if you have any questions.
Just to make sure I caught it, it can restart the SQL Server service on either 19 or 22?
Yes, in both 19 and 22, when you enable this configuration, you have to restart the service.
No, I mean, it can do it itself.
Oh, the issue you mean? Yes, in 19.
That's a big one.
Yes, it is, especially in the middle of business hours. You don't want it to be restarting the SQL service, and we have had that. So on 19, that's why I strongly recommend don't enable it. But on 22, once you terminate these long open sleeping transactions, you don't see the restart issue that much. On 22, you actually, as long as you have that job to manage that feature, you don't see, like 99% of the cases, you should not see the restart when you have those jobs to manage.
Okay, it's just a big risk.
It is. Oh yes, it does. That's why I wanted to mention, like, it does restart the service and it does cause out of memory errors. There are a bunch of stuff, yes, but it really depends on, if you ask me, do I support this feature? It really depends on how your environment is. Are those page latches causing a lot of issues for you? Like, is it causing performance impact on your server? Is that doing it? Then enable this feature and set up those jobs to manage. Or if you're not seeing that many page latches on system objects, it's just like a few in a day, no one's really complaining about your store procedures, then you don't have to enable it. Yeah, it's not a must. It's only when you have an impact, then enable this feature, because it does come with its risks.
Yeah, the baggage, even if it happens, 3, 4, 5 times a day, fine, it's not worth the instability. So if it's happening constantly, then yeah.
Yes, that's right. If you see page latches, it's there every day, and you will note, like, when people are constantly complaining, hey, my store procedure is running slow, not just one day, but it's happening like 3 to 4 times a day, or 3 to 4 days a week, it's there constantly, then you will enable this feature. If it's just a one-off thing, just one time page latches, no, you don't have to. Yes.
Nicely done.
Thank you. And on 22, it has been reliable on 22, I will say. Just don't do it on 2019. But on 22, you could do it, yeah, as long as you have those jobs to manage. And if you see a real need, do it on 22 and try it out. It should not cause, I won't say it won't cause any restart at all, but it has been reliable compared to 2019. Yes. Any more questions? Yes, Jeff, I will figure out why the echo. So when I talk, is it good? When you all mute and when I talk, do you still have the echo, or is it good?
There's no echo when you're talking and we're all muted. And there's no echo when you're muted at all. So
it's because the speakers on her end are projecting our voice. Yep. The microphone knows when it's picking up her voice.
Right.
But it doesn't know when it's picking up our voices, so that her speaker is speaking and her microphone is picking it up.
Yeah.
That's the echo.
Yeah.
I think they call it a feedback loop or something.
Yeah, I'll check it out. So if you the slide deck and the demo scripts, everything is available on the GitHub if you want to take a look. And if you have any questions later, maybe tomorrow or someday, if you are checking out this feature and if you have questions, feel free to reach out to me on LinkedIn. I'll be happy to help you out. Anything else? Thank you.
Thank you for the time and thank you for the effort.
Yes, thank you. And thanks for pulling Jeff Moden in.
Yeah, thank you.
Things are always better with Jeff Modem around.
Yes.
Normally people say they've had more than enough of me.
All right, well, I'm going to go ahead and stop the recording. Just a moment. Let's see here.
And Joe, you had to brag about how the group has got the recordings are available on YouTube. It's pretty cool.
They are. I don't have the link available at the moment, but they will be on YouTube. I have to learn from Mike how to post them. I don't know how to post them yet. Okay, recording. Stop.